What we are going to do today, as you can see, I made sure that the steps of the first week lab is very important. And organic is, as I mentioned before, the lab report and the lab, the experimental procedure and all these, how to set up your lab report is going to be something maybe it's new for most of us here. So therefore, we want to spend one session just to be able to have the introduction as to how to write and prepare our own journal. This is your own journal. Any mistake could be problematic because, as you've seen from the previous session, I gave you a copy. Sometimes I give these copies to students and they will be able to run it through and make sure that they are going to have the same result or similar result. So the most important thing is how to prepare your lab report. And from that, I was able to give you this information here in your syllabus. So there are sections in the pre-lab and some in the post-lab. I was reading through the book. The book is really very comprehensive. It's very, very helpful. Tells you sometimes the purpose is not going to be written until you conduct the experiment. But some other reference, they prefer for you to go to the literature, look through, and then try to prepare the purpose. In other words, what is the synopsis? What are you going to do? Why are you doing this experiment? So these are the steps. We are going to have the title of the experiment, the abstract, and then we are going to have the table of the chemicals. If there are chemicals, even if you have water, you can, or like sugar or salt, you need to put the name, the CAPS number. This is a chemical, an abbreviation of whatever, in other words, identity of that particular compound. And it is variable. Vary from one compound to the other, and that's how they are going to identify it. So it's like an ID for that particular compound, and it is constant across the United States and even beyond. So that's how it has been identified. You can always find these information with the books that we are going to review, or you are going to see it if you want to Google it, or you go online with the link that I gave you and provided for you. Hazardous is very, very important because we want to know what are we dealing with before even we start. So this is something that, again, you can find it from the link, and I gave you the ACS link, and in that book, when I was reviewing the book, the e-book that you have for the manual, they are referring to the American Chemical Society and how to write the lab report. So this is how we are going to go through any of these, when we're going to write our own. Some of these experiments will have questions, and you can always either leave it till the end, or if it is a pre, you can read after you read the experiment, the procedure, you will be able to answer it, or you leave it until you finish, until you conduct the experiment, and then you will be ready to answer these questions. Sometimes these questions will be answered during the experiment, so that will be very helpful to us. Then after and during the conduction of the experiment, we are going to observe. There are changes. There are, for instance, it was solution, and all of a sudden we have precipitation, color changes. Sometimes we are not going to be successful. Maybe we're not going to produce any product. That's also fine. It is possible. That doesn't mean you are going to fail the whole entire writing and you're not going to be able to present your report. Rather, this is very important. You are going to justify the result. Why didn't have something that my next bench or next group, they were able to be successful and I didn't. There must be something went through, something wrong that I did not, or I did it but it was not working for me. So this is very important when you observe. and then you're going to conclude your result. So this is then the conclusion as we are talking about. And if you look at this link, please try to go and check it. This is for any, like even if you decided to go for bio, you are a bio-premium, all of our bio-premium program, they have to do research of like literature or hands-on, and you need to present your lab report. This is a very, very good resources for you to use it for any, like, any other course or future. So these are the, how we are going to present our lab, and these are the grading rubrics that allows you to understand how is your lab report is going to be graded. So these are the things that I wanted to share with you. And then later on, we are going to go through the way that we are going to collect data, okay? In other words, every single chemical, how are we going to identify it? How are we going to write down, like for instance, the melting point, boiling point, density, refractive index, and also the molecular weight, structure. All of this information will be found in those catalogs. So this is what we're going to do next. Also, we are going to go through the calculation, and then after I finish with the calculation, I'm going to take you into the drawers. So every group will have your own drawer, and it will be assigned to you for the rest of this semester. You're going to check any, all of these glassware. It is a micro scale. It comes in a kit. So we're going to go through the kit, and then you check it, go through the inventory, make sure that you have all the equipments required. And if you have anything missing, please report it so we will be able to replace it, okay, at the beginning. And this is going to be yours for the rest of the semester. Then we are going to go back into the reference books after we finish the glassware and the calculation. So this is what we're going to do today. And I see some of you already have your own marble book. So this is what you need to keep it for yourself. When you are going to present or submit your lab report, you can take a picture or scan it and then upload it to Moodle. So I will be able to grade it, okay? So this is how we are going to go, in other words, proceed with this class. Do you have any questions for me? You have any questions? Yes.
Professor, it was hard for me to find, because I didn't write it on the lab manual, and because we don't have a link on Moodle for it.
No link. It's not on Moodle. It comes into your email, Essex email from, we were talking to everybody, and this is our bookstore affiliation with a third party. And the third party is Brightway.
Yes.
So you can find it. It should come through your email.
I didn't have it yesterday.
Essex email.
I went yesterday to the office on the library.
Okay, library or bookstore?
I went to the
Library.
Library. It's like the new entrance that they
Right.
across the street from the hall.
Okay.
And they helped me out.
So were you able to find it?
Yeah,
Okay.
I found it.
So
And
Brightway.
Yeah, I just had the biology one.
No, it should come through the whole entire classes that you registered for.
It
The
didn't.
list of everything.
It was not there. They helped me out. I don't know what was going on.
Okay, so what I would, is everybody having this issue? Did you find it on yours? So you should. But what I would really recommend, go to the bookstore in the first floor.
But they helped me out. They helped me out. They
With-
did it.
with
Yeah,
the
I got
organic?
it after.
Oh, okay, so you were able to find the
Yeah.
organic book as
There's
well,
one.
which is the intro to microscale organic chemistry laboratory, okay, by Pavia. All right, so we should be okay, everybody, right? All right, So now, if you are going to move on, because I did actually try to copy some, because the book is too huge and I cannot even carry it. So if you go into page number 609, and then the lab says laboratory calculation, notebook calculation, and lab records, and then flip into 610, page number 610, how we are going to do the calculation and then present the percent yield for the pure product. So we are going to mimic this, like, they are giving you an example. I'm going to turn off the overhead because it's over there and I need to have also to do more calculation. But please, if you need calculator, I do have some of them here. But anyway, what we did here, we had 2 of these chemicals. And by the way, in organic 2, we will prepare it. We will prepare this product, which is the isopentyl acetate, and this is the banana oil. Banana oil, that's like, whatever you have, and then, like, it's extraction, but it is going to be prepared industrial. So these are the additives that you have, like food additives or colors. Not all of them, like, from an organic product or like, natural produce. It is actually, some of them are synthetic. So this is a synthesis reaction. We are going to have acetic acid reacted with isopentyl alcohol. Isopentyl alcohol. I put together, and it is there for you. They have it in the following page. If you look through, page number 611, and then forward, you're gonna see everything. They gave you a table with the molecular weight, the amount that it is required, and then also the density, because we're gonna need it, okay? So now I want you to work with me on your notebook. If you have an extra notebook, and then you're gonna put it in your lab report, because I did some of the calculation, but I want you to do it. So you learn how to calculate the theoretical yield, and we did give them, they gave us the actual yield, and then we're gonna be able to calculate the percent yield. So over here, they use 10 milliliter of acetic acid. Acetic acid is the one that we have 5% in the vinegar. And then they took also 7.5 milliliter of isopentyl alcohol. Now, as you can see, when we wanted to calculate mole, how are we going to calculate it? We need a gram. And when you are going to divide the number of grams, which is the weight of any chemicals, divided by the molecular weight, right, which is gram per mole. So here is a gram, cancel out, that will give you mole. But I don't have a gram, I have milliliter. How are we going to convert it into gram? From a mil, in other words, volume into weight. How do we do that? And they gave you all the information required to do this calculation. Can somebody tell me? How to convert from volume to weight using what? Any idea? What did we use in our general chemistry to convert?
Density.
Or even in college chemistry? Samantha? Who says what? Sorry.
Density.
Density, absolutely. Hayat?
Yeah.
Yeah, the density is equal mass over volume. So if I have the volume, I have the density, why don't we multiply the two, and that will give you the weight. They gave you the density, right? We have the mil, which is the volume. We can always find the weight. So why don't you do that? Try to calculate the amount of acetic acid in gram rather than in mil. 10 milliliter, so 10 milliliter multiplied by the density of acetic acid, which is 1.06, and convert it into gram. Go ahead. Do it with your, if you need calculator, I do have one. Do you need one?
25%.
Okay, thank you, no problem. So let me know what is the volume, I mean, the mass that you got with acetic acid. 10.0. But 10.6, exactly, so this is it. You see that's the gram of acetic acid. And then the pentyl, isopentyl alcohol, we're going to divide 7.5 by 0.817, and what did you get? 6.12 gram. So we convert milliliter every time if you, because some of these chemicals that we're going to use, not necessarily solid, they are liquid at room temperature. So when we're going to do the measurement, we're going to measure it by the volumetric, right? Which is a cylinder or pipette. So then what are we going to do? Because we want to find out like the value in mole rather than in milliliter. So the first thing we do, we convert the volume into grams, into weight, using the density. And then after that, right, we are going to use the stoichiometry. Remember the stoichiometry that we used in the General Chemistry 1, and then we used it also in 2. So here we are. That's why I gave you these 2 steps. How are we going to determine the limiting reagent? And from the limiting reagent, we will be able to calculate the number of grams of the product, right? So everybody's clear here with me? So remember, we divided 10 by 1.06. We got the acetic acid product, which is 10.6 gram. That's how much we weigh, all right, in a starting material. The other one is isopentyl alcohol. We are going to weigh or measure 7.5 milliliter divided by 0.813. We got 6.12 grams. The second step is to convert gram into mole. How do we convert gram into mole? Divide the weight by the molecular weight, right? So first we are going to convert volume into mass, and then we take the mass, which is also in gram, a weight, and this is in milliliter. Then next is we wanted to convert the gram into a mole, because we wanted to do the stoichiometry in molar ratio, not in gram. It should be in mole, right? So here we are. This is what we're going to do next. So I converted the number of grams of the isopentyl alcohol into moles, and I want you to calculate it. So you divide, then you multiply. Remember when we had, like, these two, we multiply it by the molar ratio between those two chemicals. In other words, this one and the product, and we found out that it is 1-to-1 molar ratio. This is balanced equation. It's 1-to-1 molar ratio. This is the ratio. This is the threshold. It's a very important step, that you put the number of moles of the product over the number of moles of the starting material. After you do the calculation, so I did it in one step, and I want you to give me the number of moles. So when you divide, try to divide 6.12 by 88. So what did we get? What is the number of moles here? Can you give it to me?
0.0693.
69. So this is good enough, or 4 if we want to round it, okay? But we have 3, so I will put 4 here because we have 3 digits or 3 significant figures. Do the same thing for the acetic acid. So this is the product. This is the isopentyl acetate. In this case, if I want to prepare the product from isopentyl alcohol, I will get 0.0694 mole. what if we wanted to prepare it from acetic acid? Because whoever is gonna have the least number of moles, which should be the limiting reagent, right? So everybody remember that? So now we're gonna do the same thing. I'm going to divide 10.6 divided by 60.1, and what did we get when you divide those two? 0.176. So which one is bigger, is more moles? This one. So that is excess, and this is the limiting. So then you decide this, then it is, that guy is the limiting. Reagent. And from that, I will be able to calculate the product. Now they also gave you the product. How much was produced? How much was produced? We do have the, like, you know, the molar mass of it. We do have the density, and this is how much was purified and produced. This is the experimental, but we have to find the theoretical, right? So the theoretical yield is going to be this guy, which is a mole. Now I want to convert it into gram. How do we convert mole into gram? How do we convert mole into gram? You see, when I have mole, multiply with the molecular weight, you will get the weight. So that's what we're going to do now, okay? So what we have, this is the mole, right, of the product. So the isopentyl acetate, the mole, right, which is equal, in other words, you multiply it by the molar mass of isopentyl acetate, right, to give you number of gram of the product. But this is theoretical. Theoretical. That's in theory, right? That's what we're doing on the board. But the actual amount that was collected was 3.81. So let's do that. Let's find out. Number of moles, it was right? That one, 0.0694 mole, multiplied by 130.2 gram per mole. So we cancel out the mole, and that will give me how much theoretically should be collected. So I'm going to multiply 0.0694 multiplied by 130.2. What did we get? 9.35. So we're going to have like 4. In other words, I'm going to round it, so it is going to be 9.04 gram of the isopentyl acetate. Theoretical. Okay? Now we get to the end. After you find the theory and you have the experimental, that's how much you collected, like on hand. And then you're going to have the percent yield. Percent yield is equal to the actual, right, weight that you collected during the experiment divided by the theory. And then you multiply it by 100. So this is what we're going to do. We have 3.81 divided by 9.04 gram, and then multiply by 100. That should give you the percentage. Okay? So it's gonna be around 42 something percent, right? 3.81 divide by 9.04. It's 0.421 multiplied by 100 will give you 42.1. So that is the final 42.1%. Now, in the industry, this reaction is not going to be good. At least in the industry, we should have 50 and higher percentage of your pure product to be able to utilize and implement such procedure. Because this reaction probably going to be used in another way, using different acids. Maybe they are not going to be having acetic acid. Maybe they're going to have acetic anhydride. Maybe they are going to use a different, stronger hydrochloric acid, sulfuric, but instead of that acid that they use. That's what we do in the research and in the R&D. Because we're going to keep trying and trying and trying until we get to the best percentage of our pure product. But this is basically what they are doing with any preparation of any product, like synthetic. In other words, synthesizing any chemical compound, whether it is a biological compound or a chemical compound or any other compounds, okay? Do you have a question about these calculations? This is what we're going to implement or use when we are going to prepare a compound, okay? And we want to find out how sufficient or efficient it is our own practical. Because as I told you, some of you probably will be able to find a percentage of over 50. Some of you will find less, and it depends on how much you are going to recover. Because this recovery is very, very important. But it also involves a lot of errors. And these errors could come with the human errors, transportation or transferring from one equipment to the other, glassware. Sometimes we lose some of these chemicals through purification, extraction, recrystallization. So it is very important that we keep those compounds. After you have the crude compound, then you go through purification, and the last one, therefore, if you look at this versus even here, versus that one, this is the theory. This is what we expect in the best conditions. We would expect to collect at least 9 grams. But in reality, they collected only 3.8. So these within, the steps of purification, extraction, recrystallization, we lost some of this compound. But this is the steps. These are the steps that you are going to go through. In this semester, we are going to learn how to use all these techniques of preparing the pure product. And hopefully we will be able to do probably a couple of these, extraction and then collection of a pure product. But we're going to use extraction, purification, recrystallization, and also distillation, and using column chromatography if we wanted to purify. So these are the techniques that you're going to learn. Not necessarily only here, because if you, let's say, wanted to purify a mixture of a gene, and then you prepare the sequence, and then you want to purify it. So you take it into column chromatography, and then you purify it, and then take it into the spectroscopy, like mass spectroscopy. So all of these are going to be learned here, but not necessarily for organic chemistry only, because you can use it at any other biological or biology or biochemistry labs, okay? Yes.
I know you repeated it multiple times, but I want to make sure that it sticks on my head, because when I see a problem like that, I want to be able to. We are taking those two acetic acid and isopentyl alcohol, and we're gonna
Mix them
mix together
together.
so we can get the product that is isopentyl acetate.
Right.
That's the steps to make them.
Right. So this is gonna be in first, and then also we're going to have a couple drops of sulfuric acid. Now it's H stands for the acid, you should know that, everybody, right? So instead of saying H3O plus or H plus and slash H2O, you can always have it like that. That means we are going to have what? When you see such things on the arrow, what does that mean? What do we call this guy? It's not going to get involved in the chemical reaction, rather it is going to accelerate the reaction. What do we call them? Catalyst, thank you. This is a catalyst. It's not part of the product or reactant, rather it is going to be added to speed up the reaction, to let the reaction go through, okay? So I think we're done with this part. And you need to, if you go into your manual, you're gonna see it. You're gonna see all these steps, but they also showing you the purification step using like other methanol, ethanol as a solvent that we use to recrystallize. But then, at the end of the day, they collected 3.81 grams. So this is what we are going to do. I think we're done for this part.